Good morning, friends. I welcome you all to my YouTube channel. I'm myself, Dr. M.H. Annaya. And in today's video, we are going to have two problems. That is, a problem on a section plane, that is, on sections of a solid, and also its development is going to be studied today. See, friends, what is the question in store for today's problem? A cylinder of height 80 mm resting on one of its circular ends on HP. So you got a the cylinder, which looks like a rectangle in the front view and as a circle in the top view. And they have not specified what is the diameter of the circle. They have simply given the height as 80 millimeter. That's all. Only the height of the object is being given as 80 millimeter. And he says it is cut by a section plane which is normal to VP, now inclined to HP. Friends, whenever a section plane is normal to VP, it is seen as a line in the front view. We have already worked out a lot of problems on such questions. And friends, it says it is bisecting the axis, so we can mark the center of the axis. We know the height, we know the section plane is bisecting that, but they have not given what is the angle made by the section plane with HP. No doubt it is normal to VP, but it is inclined to HP. Friends, if the section plane were horizontal like this, and if it were cutting like this, parallel to the base of HP, then we would have got a circle here, and the diameter of this would have been the same as this. But here they have not given. It is cut by a section plane such that the true shape, TS means the true shape, is an ellipse with major axis 60 mm and minor axis 40 mm. Friends, assume it is cut by a horizontal section plane. Then the diameter of this will be the minor axis, and if it is slightly inclined to HP, then friends, very obviously, the true shape you are going to get is going to be an ellipse with the maximum dia or the major dia of the ellipse as 60 mm and that of the minor axis as 40 mm. Friends, it's a very clear indication. Always, if it is cut by a section inclined to HP, if the true shape is an ellipse, then the minor axis of the true shape is the diameter of the circle. And diameter of the circle means the diameter of the cylinder. Friends, this concept is very, very important. Unless you know this concept, you can never work out this problem at all. Friends, now I am going to have a section plane cutting this cylinder, and before that let me mark all these points on that. Friend, this is A comma A1, this is BB1, CC1, DD1, EE1, FF1, this is GG1. Just to save space I have done like that, friends. Friends, this is A dash, this is B dash, then this is C dash, A, B, C, this is D dash, and this is E dash. Along with this you have got G here, and along with this you have got H, and here friends you have got A, B, C, this is D, D dash, and F dash. This is how. Similarly for the bottom piece, friend, I will show only few of them. This is A1 dash, this is E1 dash, this is C1 dash. Along with this you have got other also. Friends, we know very well, the section plane is not horizontal, it is inclined, and whatever the length you get here along this bisector of the vertical axis of the cylinder, that is going to the major axis. So what I do, the major axis 60 millimeter. So friends, I will take the mid height or midpoint of the cylinder From there, I just draw two arcs on either side of this. And friends, if you join that along with these friends, you are going to get, this is the section plane. I will call it as SS, which is bisecting the axis of the solid. Friends, now friends, we are going to retain the lower part of the cylinder for drawing the development and also to get the front view. So this is the portion of the solid that is retained and this part is being drawn out. Now friends, this portion below the section plane which is shown by dark line is the front view of the solid, and this is the top view of the solid. And friends, remember, whenever any of the prisms, cubes and cylinders are cut in between the top surface and the bottom surface by any section plane, either horizontal or inclined to HP, then the complete top view, whatever you see of the solid, is totally section, because you can just write like this. So I am going to section this solid. And friends, this is the top you have got, and since there is hatching, I will call this as STV. STV means sectional top view. Friends, we have got the diameter of the cylinder, written the front view and sectional top view, and this works out to the diameter, minimum diameter or minimum side of the ellipse, that is the minor axis, that I will say 540, because the true shape of the ellipse, true shape of the section is an ellipse, and the minor diameter is equal to the diameter of the cylinder. Friends, next we have to get what is known as the inclination of the section plane with HP. What is that, friends? This SS is perpendicular to VP, and if you are able to measure this angle, this will give you theta, this inclination of the section plane with the HP. Then friends, after this, you have to show the true shape of the solid as an ellipse. Friends, I will just remove this, a part of this, for drawing the other part. That is the true shape I have to mark. How to mark, friends? From these points where the extreme generators are cut by the section plane, I am going to draw two perpendicular lines perpendicular to SS. So friends, this is one such line, and this is the second line, friends. Remember, this radius is equal to 30 mm and this radius is also equal to 30. So totally it is 60 millimeter, friends. Now friends, I am going to draw a line parallel to that, parallel to SS. So very obviously, this is parallel to SS, but it is perpendicular to this line. So friends, here I should get what is known as the true shape of the section, which is going to be an ellipse. And only based on that, we were able to find out the diameter of the cylinder. Friends, just to show, just see here, friends, all the generators, all the 8 generators, AA, BB, CC, DD, etc., are all cut here, friends. Now, friends, I will mark this point on A as 1, this is 2, and this is 3.4, and this is 0.5. Since there is no place, I am just marking only alternate points where the solid is being cut. So these are all the points, friends. So you will be having totally 8 number of points on AA, BB, CC, etc. Friend, how to get the true shape here, friends? Now see, the point 1 is on AA. 1 is on AA. At what distance? At this distance. So mark the distance on this perpendicular line and say this is the point 1. 1 is on AA. And similarly 4 is on this point. It will be at the same distance, friends. So this is point number 4. This is 1, 2, 3. This is 4. This is 5. Sorry. This is 5. 1, 2, 3, 4, 5. This is 6. This point is going to be 7. Sorry. This is 7. So 5 is exactly opposite to A. 1, 1. This is point 5. Friends, similarly here, 7 is nearer to this on this line. So through this I will draw one more line and mark on that the point 7, 7 closer to this. See, this is 7, 7. Opposite to 7, 7 is 3 at the same distance 3. Friends, you got 1, 2, 3, 4, 5, 6, 7. This is 3 and 7 on the opposite sides. Friends, like this we are going to get points and all. So if you draw through this point, you will get 2 more. So let me complete that part also. So from here, you are going to get point 1, 2, 2 and 8 on this. So this is 2 and that is 8. Similarly on the other end, friends, if you are taking a line through this, friends, you will get 2 more points here. And friends, all these points are symmetrical about the line 1, 5. Join all these points by a smooth continuous curve to get the true shape of the ellipse, a true shape of the section, which is going to be an ellipse in this case of cylinder. Friends, section this or hash this by drawing number of lines parallel to or at an angle of 45 degrees to the horizontal. Friends, this is the true shape of section TS, which is an ellipse. And friends, you know very well, since 1 5 is parallel to section plane SS, and whatever the dimension you have got here, that is 60 is this dimension 60. So I can just mark it here, this distance as 60, friends. And similarly, this distance between 3 and 7 is the diameter. This is 7 and this is 3. This is equal to the diameter of the circle, which is also the minor axis, which is 40 millimeter. Friends, we have got the true shape, which is an ellipse. It has got major dia 60 mm, minor dia 40 millimeter, and the inclination of the section plane can be measured as per the question. And friends, this is the complete projection of the solid, wherein you have got the front view. This part is a sectional top view, which is a circle totally hatched, and this is the true shape of the section, which is the mirror image of the cut part. That is, if you hold a mirror parallel to the section plane, the mirror image is the true shape of the section, which is an ellipse. Friends, finally, we have been asked to draw the development of the lateral surface of the cylinder. So friends, as I told you before, we are combining two portions of the solid. That is, one is the section and other is the development. Friends, you know very well, if you have a cylinder, if you cut it open along one of the generators, you are going to get a rectangle in the development. So let me draw that rectangle, which will have a height equal to height of the object, which is equal to 80 mm, and the length of that is equal to pi d, pi into par p, or 2 pi r. Both are same, friends. And friends, now here we have divided the circle into 8 equal parts. So also this width is going to be divided into 8 equal parts by the method of division of lines. And friends, here we'll have 2 more in between. This is 4 divisions, 5, 6, and this is 7 and 8. Friends, we can start from anywhere. Let me say I am starting from this point 1 and this point is 5. So I am going to start from point 1, 1 or AA. So friends, this is A, B, C, D, E, F, G, H, and again A. Similarly, for the bottom edge, we are going to mark it as A1, this is B1, this is D1, F1, H1, and again this is A1, this point. Friends, the point 1 is on generator AA. So simply draw a horizontal line from there till it touches AA. Extend that line till the last. So this is going to be your point 1. I will mark here. And then 2, 2 and 8, 8. 2, 2 is on BB, 2, 2 at this height, and BB, and similarly on the other end you are going to get a point on HH. So friends, next comes 3 and 7 to an arrow. 3 and 7 from the midpoint. So this is 3. Now we got 1, 2, this is 3, and similarly 7 friends. So this is our point 7. We'll mark later on. Then friends, this point 4 and 6. On the next line, 4 and 6 fall on this, 4 and 6. So this is point 4 and this is point 6. And finally friends, the last generator E is cut here, that is point 5. So through this you draw a horizontal line and this is going to be our point. So you'll mark all these points in order. This is 1, the point 2, 3, 4, 5, the highest point, 6, 7, 8, and again 1 on AA. Friends, what are the points you got? So you join them by a smooth continuous curve to obtain the development of the lateral surface of that part of the cylinder below the section plane, which is retained for the purpose of development. Friends, we will have this joint because the bottom edge is not touched by the section plane. So this is how we are going to get the development of this part. If I call this part as P, this will give you development of P, the lower part of the retained portion of the solids. Friends, you see we have covered two aspects of solid. That is, one is the section of solid, the other is development of the same. So friends, I am very confident that you have followed the complete video, and friends, go through the complete video, and if you like this video, share this information with all your friends without fail. And in case if you have not subscribed to my channel till now, please do it today along with your friends. Thank you for watching my YouTube video. Have a blessed day.